All right, so today we're going to be talking about the equations of circles. So we've done a lot of exploration as what happens like in just random like space, what happens with respect to circles. We looked at the angles that are created by lines that intersect circles. We looked at the angles inside of circles, angles outside of circles. Same thing as we looked at segments both inside and outside of circles and how we can kind of relate them and what different, relationships really emerge from those things intersecting. So now what we want to do is we want to go, okay, that's great for circles and all, and we're working with a lot of algebra, and we want to know specifics. So we're going to look at, okay, how do we define circles on the coordinate plane? Because I know it's something that I can draw, but if I try to input that on a graph, I have absolutely no idea how it's going to work, okay? And so here's kind of the basis of it. So before we really get into what the equation is for a circle in the coordinate plane, we kind of need to look at where it comes from first. So first thing I want you to guys recall is what the actual definition of a circle is, okay? And the actual definition is the set of all points equidistant from a fixed point, okay? So that fixed point we call the center, right? So if we have circle C here, right? So that center point, from that center point, every single point that makes up this circle, right, is the exact same distance away from C, right? Now that distance, that uniform distance is what we call the radius, okay? And the radius is the distance from any point on the circle to that fixed point. So in this case, we would call it R. Now, I know that a lot of times you guys think of radius in terms of it's a little segment that goes from the center to any point. But really what we're talking about when we mention radius is the distance of that segment, okay? So, using those ideas, we're going to look what happens. Let's just say we had a circle in the coordinate plane first, okay? And we're going to use those two definitions to come up with this idea, okay? So, one of the things that we're going to need, since we talked about distance, right, need to remind you is the distance formula. So who can tell me what the distance formula is? Oh, come on now. Someone's got to be reminding me. Anyone? Ben? Okay, is what radius squared? No. I'm curious what you're the distance from. So again, we're not just talking about circles. So I'm asking more of a recall question. Remember the distance formula that we used earlier in the year?
I was thinking of diameter.
Okay. Who can come up with distance? So let's just say my point here is 0, 0. Okay, and if you look at this guy, if you look at every single point that you can find on here, you know that if I go up here, I went up 5 units. If I went over here, I went over 5 units. Right? And then so you can assume that if I go up here and reach this point, this length will be 5 units. Okay? So essentially we know what the radius of the circle is. Okay? It's 5. But how in the world do we get to be able to define this point or define this circle? Okay, so the reason that I asked you to find the distance formula is so think about it. So the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay. And again, this is essentially the Pythagorean theorem, okay? Because this point right here is essentially the length of, so let's just say I wanted to find this guy right here. x1 minus x2 would be this distance here. And then y1 minus y2 would be this distance here. And so it would make a right triangle, and that's kind of where it comes from. Okay? So to make it really look like the Pythagorean theorem, right, let's just square both sides. Okay? So another way that you can look at the distance formula is I can go the distance squared is equal to x1 minus x2 squared plus y1 minus y2 squared. Okay? So that's another way that we can look at this distance formula. Okay. Now, the reason I asked us to kind of find that distance is we already know that the distance from 0 to any point on that circle is 5. Okay? So we actually know what D is already. It's our radius. So, if I was to write the equation, let's just say, of this particular circle, I know that 5 squared would have to equal x1 minus x2 squared plus y1 minus y2 squared. Okay. Now, we can come up with a couple of different points that are actually on this circle, right? But let's just say we don't know any of the points. Like, we want to be able to find what one of those points are. Okay? The only point that we know for sure is where the center of this thing is. Okay? And that's 0, 0. And if you think about the distance, right, no matter which point I choose along here, right, the second point will always be 0, 0. Okay? So for this case, 5 squared would equal x1 minus 0 squared plus y1 minus 0 squared. And that'll be true for any point that's on the circle because we know we're taking the distance from the point on that circle to the point 0, 0. Okay? So we can simplify this to 5 squared is equal to x1 squared plus y1 squared. Or 25 is equal to x1 squared plus y1 squared. And believe it or not, that'll give me any point that's on the circle. I mean, try it. See for yourselves. Okay, so let's just pick a random point that we can see on here. So I'm going to go right here. Okay? And that point is -3, +4. Okay? So -3 is my x, so 25 is equal to -3 squared plus 4 squared. 25 is equal to 9 plus 16. 25 is equal to 25. Yep. So that point is definitely on the circle. Okay? Well, that was an interesting way we just did that. All right, and that's really nice if my center is 0, 0. Okay? But now let's look what happens if my center is not 0, 0. Okay? So if my center is not 0, 0, okay? Again, I want to try to find the distance from whatever the center point is to any point on the circle. Okay? Again, we can rewrite this as more of like a d squared is equal to x1 minus x2 squared plus y1 minus y2 squared. Okay? I want to think about how to write the equation for this circle. So the first thing I'm going to want to find is maybe where that center is. Okay? Maybe where that center is. So I'm just going to pick some points on here. All right, I'm going to draw essentially lines to connect to, like, oh shoot, 2 points which I think are essentially the opposite sides. Okay? And forgiving this thing for being a little bit off. Right? So just kind of using this idea, where can we assume that the center of this circle might be? Where does it appear to be? Again, my ruler was a bit off, but it appears to be right here. Right? And that's at point 2, -1. Okay? Now, what's the radius of this circle? Well, let's find out. I know if I move from here, and I know that this point's on here, I move up 1, 2, 3, 4. Okay? Now let's see if that's uniform. I'm finding another point and going, okay, is this 1, 2, 3, 4 points away? It is. Okay? So what I now know is that my center is at 2, -1. I know my radius is equal to 4. So let's try and kind of write an equation that will give me any single point that's on the circle. Okay? We're going to use the distance formula. Okay? Since I know radius is really our distance, I know that this is going to be 4 squared is equal to x1 minus 2 squared plus y1 minus -1 squared. Which would mean that this is 16 is equal to x1 minus 2 squared plus y1 plus 1 squared. Okay? And this will give me pretty much any single point that's on that circle. Okay? I don't have to go ahead and FOIL it out. I can if I want to. But there's really no point at this point. Okay? Because if I plug in some values, so if I try plugging in this point right here, this point right here, or this point right here, right, you'll see that this equation works out. Okay? So this leads us to kind of, all right, how do I generalize this for any circle in any coordinate plane? Okay? So let's just say we have a circle with center h, k, and a radius r. Now what that really means is I just have some arbitrary circle out in space on the coordinate plane somewhere. Okay? We don't know where. It could be somewhere near the x and y axis. It could be far off in, in the hundreds away from the x axis. It doesn't really matter. Okay? The way that I would find that circle has nothing to do with its location necessarily on there, except for the fact that I know my center point is at this value that's out there. Let's just call it h and k. Okay? Sorry, And then my radius, again, would be the distance from the center to any point on that circle. Okay? What we found, right, in that in order to write the equation of the circle, right, each one of these equations always equaled r squared is equal to x minus h squared plus y minus k squared. And this is our equation of a circle in the coordinate plane. Now, the reason the x1, y1 went away in here is because we're just trying to find any point that's on the circle. We're thinking general case. Okay? So this is the equation that'll give me any point that is on that circle given its center and its radius. And I can use that to go both forwards and backwards. I can actually look at an equation of a circle and tell you exactly where the center is and what the radius is. Okay? And that's what we're going to do on these next few example problems. Okay. Right. So for each one of these, we want to identify their center and radius, and then we want to sketch the graph given these equations. Okay. So remember that the equation of a circle, r squared, is equal to x minus h squared plus y minus k squared, where our center is at hk and our radius is equal to r. Okay. All right, so let's look at number 1. Okay. Can I find what my center is for number 1? Does anyone know what the center of my circle would be for number 1? Yeah.
Would it be 2, 3?
Perfect. That's exactly right. 2, 3. Okay? Because this point is my x coordinate for my center, and this point is my y coordinate for my center. So, looking at this equation, this would be the x coordinate for my center. This would be the y coordinate for my center. Okay? So I now know where the center of this circle is going to be. So I'm going to go over to 1, 2, and I'm going to go up 1, 2, 3. And here's my center. Okay? Now here's where it gets tricky for my radius. Okay? Remember that this is r squared here. Okay? So this value, this 6, is equal to r squared. It's not my radius. Okay? R squared is equal to 6. So if I wanted to find what my radius is, what would I have to do? I have to take the square root of both sides. Right? So this is equal to the square root of 6. Now you're probably going, how in the world am I supposed to sketch a graph in here, or sketch a circle in here that's got a radius of the square root of 6 with the center over here at 2, 3. Okay? This is why I said sketch. Okay? So I know that the square root of 6 is somewhere between, 2 and 3. Because 2 squared is 4, 3 squared is 9. Okay? So I'm just going to kind of guesstimate that I've got, 1, 2. So it's somewhere between 2 and 3. So I'm just going to put a point somewhere around between 2 and 3. Okay? And so I'm going to approximate this as my radius, which is square root of 6. I'm going to do the same thing to kind of all 4 directions. So I'm going to go 1, 2, about here. Now 1, 2, and about here. Over 1, 2, and about here. Okay? Now I'm not going to make a square. What I'm going to do at this point is, again, we're just sketching this thing. It doesn't have to be perfect. I'm just going to try to create this circle. And Mr. Kiefer is very horrible at drawing circles. All right. And this is a rough sketch of a circle with center 2, 3, with our radius of square root of 6. Okay? And this circle represents, or sorry, in this equation right here is the equation for this circle. Okay? Let's try number 2. Who can tell me what the center of this circle is? Ben.
Negative 1, 2.
-1, +2, exactly. Here's H, here's K, -1, +2. So -1, +2. Now remember that this is equal to r squared, so r squared is equal to 15, which means my radius is equal to the square root of 15, which is somewhere between 3 and 4. Okay? So I'm going to go down 1, 2, 3, about right here. 1, 2, 3, about right here. 1, 2, 3, about right here. And 1, 2, 3, about right here. Okay? And now I'm just going to create my circle. Oh, I took that one a little too in. And Mr. Kiefer is terrible at drawing circles once again. Okay? But this 1, 2, 3. Yeah, my points are right, but oh, that's an ugly circle. Okay? But again, that's what the equation gives us, and that's what's nice and neat about this thing. Okay? So now what we want to try to do is we're going to go backwards. We're going to say, all right, here's the center of this circle. Here's the radius. Write the equation for this thing. Okay? So just remind us again, center equation for a circle is r squared is equal to x minus h squared plus y minus k squared. Okay? So if I know my center is at 1, -1, and I know my radius r is equal to square root of 221, right? So if r is equal to the square root of 221, then what does r squared equal? (221). There you go. Okay? So since this value is r squared, that's the whole reason we needed to find it. Okay? So I know r squared is 221, so I can go 221 is equal to x, and then my h is +1, so it's -1 squared plus y, and then this is my k is -1, so it would be minus -1 squared. And it's just that simple. That's the equation of my circle. Okay. I'm going to give you guys about a minute, and I want you to try to write the equation of this, the circle for number 4 on your own. Write the equation for the circle for number 4 on your own. Who can tell me what they got? Who wants to share? Nick. Wait, 3, sorry, say it again.
X plus 16.
3 equals x plus 16?
Yeah, well, and then squared plus y minus 9 squared.
Okay. Anyone else see anything different? Alright. So remember, my radius, r is equal to 3. What's this value supposed to be? R squared. Exact. So r squared now is equal to 9. So this is where we have to be careful. Okay? So the HK, perfect. But we always got to be careful that this, what it equals, is not what my radius is, it's what my radius squared is. Okay? And that's why when we were graphing these circles, right, even though it was 6 here, my radius was the square root of 6. Likewise, my radius was the square root of 15, but there was a 15 here. So we just have to make sure that we are careful. Okay? But great job. All right. Any questions on this? Yeah.
If you put 3 squared instead of 9, does that?
No, you can write it as 3 squared. Just when you're, like, for example, on the assignment today, 3 squared is 9. It's just easier to simplify it that way. But that would not be wrong. Okay. On the assignment, it might mark you wrong. But just FYI. Yeah. Any other questions? That was a good question. No? Okay. All right, well, I'm going to be posting this video momentarily. You guys have an assignment to work on today for equations of circles. Please let me know if you guys have any questions at all. All right, and get to work.